for Chapter 17 problems, we're looking at number 11, which is asking us to draw the dienes. So cyclohexadiene is a cyclic structure, 6 carbons. There's 2 double bonds, and one starts at 1, and the second one starts at 3, so we have cyclohexadiene. To do this heptadiene, we have carbon double bonds at 2 and 4, and we're given the specific alkene stereochemistry, and at 2 it's Z, so I will usually start with the Z, and in order for it to be Z it has to be cis, and this is 1, 2, and then 4 is going to be E, so that is opposite. 1, 2, 3, 4, 5, 6, 7. So that's how you would go about drawing those two. Here we're looking at butadiene with 1 equivalent of HBr at 0 degrees Celsius. So there's our butadiene. It's cold, so we're going to expect 1 product. Our electrons from the nucleophile here are going to grab a proton, so we have a proton transfer. This double bond stays where it is. So we have 1, 2, 3, 4. My hydrogen goes to the carbon with more hydrogens. Again, a positive carbocation here. And this will attack the carbocation. And we add the Br at this position and 1 here. This is the 1,2 addition product. So we had a proton transfer, nucleophilic attack. Sorry, that is the 1 product. All right, here we're looking at methyl cyclohexadiene. At 2, we have an ethyl, methyl at 3, HBr. This is at room temp, so we're going to expect a couple of different products here. We have, if this is numbered 1, 2, this nucleophile can attack here. That will give us the 1,2 adduct. And then if we look at that carbocation, this is resonance stabilized. So the carbocation ends up there. And that can attack there. So this is the 1,2, this is the 1,4. And of course you can get the products from the other end as well. And that is the result of numbering it in this direction. So we get a proton transfer here. And this bromine can attack the electrophile. Give us the 1,2 product, and of course we have this resonance stabilized product. and the other one for product. To predict the Diels-Alder products here, we want to flip that diene file in a direction that works for us. Draw your mechanism arrows. So one of these will be up, the other one is down, because we started with a trans double bond. I formed a new bond here, here, and then a double bond here, and then I have that bridgehead carbon, which of course you could draw this way as well. So that's that product. Here I need to flip both of these products around, so I'm just going to actually redraw these. New bond, double bond, and then the bridgehead carbon. There's the two versions there. Then we have some more Diels-Alder. Again, I'm going to redraw these. Draw my mechanism arrows and then look at the bonds that are being formed. So I have a new bond here, here, double bond here, then my bridgehead carbon. All right. And then in this one we have a triple bond. I'm going to redraw it again so it's in the right direction. So our double bond, we have a double bond there because of that alkyne. So we have the 2 sigma bonds, the pi bond that's formed, and then we have the bridgehead as well. And then you have the OME there. So that one's, neither of those are pretty drawings, but that's the structure that you would have there. All right, here we're looking at how to figure out what Diels-Alder reagents that we use, and we just draw all of those arrows backwards. So this is a bond that was formed here, So this is going to go here. The pi bond that was formed will go here. This sigma bond breaks, and then we send that there. There is one bridgehead, so we have a 5-membered ring. 2 double bonds here, plus the 2 aldehydes. And this is the same thing. You want to find where your cyclohexene is. This is a sigma bond that was broken here. This is the other one that's broken. That goes there. Here, because it's not a bridgehead, we have a non-cyclic diene. So those two would get together to form that Diels-Alder. Alright, same thing here. Find your cyclohexene. So we'd have that one. So all of these, we're just drawing the arrows in the backwards direction. This one's got a bridgehead, so we have a cyclic stricture. So that's what we're going to see there. All right, for these, just really what you're concerning yourself with is doing the structure. Don't worry about the con-rotatory pi bonds. So we're just going to form a ring here. So I'm going to redraw this one so they're oriented in the right direction. So I have the CH2 next to the O and then that carbon double bond here. Then for my structure, I'm going to form a double bond here. These electrons will go to form a new sigma bond, and those will form a pi bond there. So here is the double bond that I formed. There's a new sigma bond here as well. That carbon and another carbon, and then there's a new carbon double bond there. So that's the structure that you would see there. For B, again, we want to draw them kind of in proximity to each other. So I'm just going to flip things around here. So this carbon here is the one at the top, and we draw our arrows very similarly. This is going to form a new sigma bond. This will go here, and we're going to form a carbon double bond oxygen over there. So this is here before. I have a new carbon double bond oxygen, and I broke that bond there. This is new, and then I have a new bond right there.